How to do blood type problems, take 2. So first things first, on this test you will have to be able to make a key for blood type. So if you have blood type A, you might have an IA from one parent and an IA from your other parent. That would be a homozygous type A. There's a second way to have blood type A, that's an IA from one parent, and you get the recessive little I from the other parent. Since IA is dominant over little I, you are still type A, just like this person would be. Type B works much the same way. You could get an IB from one parent, an IB from the other parent, or you could get an IB from one parent and the recessive little I from the other parent. And IB is also dominant over little I, just like IA is. So there's 2 different genotypes that can make type A and 2 different genotypes that can make type B. Now if you're type AB, there's only one genotype, IA, IB. Since they are codominant to each other, if you have both of them, they both show in your phenotype. Codominant, they're like co-pilot and pilot. They're both there, the pilot and the co-pilot. And then finally, if you have the homozygous recessive genotype, then your phenotype is type O, and you are little I for your genotype. And blood type is often called blood group. So some people were a little bit hung up on that nomenclature. But anyway, here we go. Number 1, a woman with type O blood. Bam, bam. Type O, there's only one way to be type O. She's little I. And a man who is type AB. Woohoo! Only one way to be IB. AB, I mean IA, IB. So she's little I, he's IA, IB. Are expecting a child. What are the possible blood types of the child? So let's make the Punnett square. This is kind of an interesting one. If you have one parent who is type AB and the other parent who is type O, they will either have type A babies, type B babies, and that's it. So none of the kids will have the same blood group or blood type as either of their parents. That's kind of cool. The kids are going to be either A or B, and one parent's AB and one parent's O. Anyway, there you go. What are the possible blood types of child whose parents are both heterozygous for B blood? So if you have B blood, these 2 are the same, so that's homozygous. These 2 are different, so that's heterozygous. So it's IB little I crossed with IB little I. Whole lot of B type of blood here, but there is one. It's B, 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 and finally we get an O. So 75% B and 25% O. Jill is type O, so she's little I. She has 2 older brothers, one with blood type A and the other is type B. What are the genotypes of the parents? Okay, interesting. All right, if she's type O, then each of the parents has to have a little I. So they can only have one other allele. Now, one kid is type A, so there's got to be an IA somewhere. And the other kid is type B, so there's got to be a type B somewhere. But if you start with an O, that kind of makes it easy. And then you have IA, IB, IA, little I, IB, little I, and there you go. So here's a type A, here's a type B, here's a type O, and there's an AB too. So both parents have to be heterozygous. Oh, I am so sorry. I'm doing that whole thing and not even showing you at all. There it is. All right, so the next one Determine the possible genotypes and phenotypes with respect to blood type for a couple whose blood types are homozygous A. That's homozygous A, they're both the same. And heterozygous B. Heterozygous B, if you look back at your key, if you're type B, you're either homozygous or heterozygous. All right, so half their kids are type AB, and half of their kids are type A. None of the kids are type B. A test was done to determine the biological father of a child. The child's blood type is A. The mother is type B. All right, so the child is type A. So the child has an IA. And so that means one of these guys has to have an IA. And I'd imagine this one would too. And the mom is type B. So she's either IB, or IB little I. So let's look. She can't be here, because if she had an A allele, she wouldn't be type B. So she has to be over here. So let's put an IB in right there. Now we don't know if it's this one or this one, so we're just going to leave the other one blank for now. Just like we don't know that. So let's fill in what we do know. IB. All right, so let's look back at the problem. The child is type A. So the kid could not be here, because that's AB, could not be there, because that's got a B in it. So they'd have to be here. Now, if the mom has IBIB, then the kid would have IAB. So the mom must have a little I. And the dad has to have the A, because the kid got an A from somewhere, and he certainly didn't get it from mom. There's no way mom has an A. So the dad has to have an A. The first gentleman has a blood type O. Well, that's this, so that's no A. And the second gentleman has a blood type AB. So could he be IAIB? That would still give us, if this was a little I, if this was a B, little I, there you go, IBIB, and that works. So it is the AB is the dad. All right, suppose two newborn babies were actually mixed up in the hospital. In an effort to determine the parents of each baby, the blood types of the babies and the parents were determined. So, Mrs. Brown is type B, Mr. Brown is type AB. So let's make a punnet for the Browns. And let's make it so you can see it. And we'll make a punnet for the Smiths. Okay, so Mrs. Brown is type B, so she has an IB. We don't know if it's IBIB or IB little I. Mr. Brown is type AB, so he's IA, IB. So let's fill in our partial punnet. All right, so that's one parent set. And the Smiths, we have a type B again. But Mr. Smith is also type B. So, and we don't know if they're IBIB or IB little I, so we're just going to leave it blank. Now let's look at the babies. Baby 1 is a typo. Well, no, 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 no. No, no, no. Aha! This is the only possible for the typo baby. So baby 1 is Smith if they are heterozygous. IB little I. All right, what about baby 2? Baby 2 is type A. Can baby 2 be the Browns' baby? No, no, no. Yes, if Mrs. Brown, if Mrs. Brown is heterozygous, then Brown has baby number 1. If okay, there you go. So that is your set of pedigree problems.